Hi everyone, this lesson is our last minute Lucy Conic review covering circles, ellipses, hyperbolas, parabolas, and systems of nonlinear equations. So let's get started. This first question, we're going to start with a warm-up. The question says, write the equation of an ellipse with major axis length 16, and the focal points are at negative 5, 0, and 5, 0, and then we're going to sketch the graph. So if my foci are at negative 5, 0, so there's negative 5, 0, and then you have 5, 0 here. I'm going to put a little F here showing me that those are my focal points. And then 5, 0 here, and then negative 5, 0 here. So therefore, that means that if this is 5 to the left and 5 to the right, that means that my center is going to be at 0, 0. So starting off, this is going to be x minus 0 quantity squared plus y minus 0 quantity squared. And because this is an ellipse, these are both positive, and this will be equal to 1. And then underneath these values, okay, we're going to have our values going in the x and the y direction. It says the major axis has a length of 16, which basically means I'm going to go to the right 8. So here's 8 to the right, so that's going to be 8, 0, and that's one of my vertices. And then negative 8, 0 this way. And what that means is if I go left and right 8, that means that underneath the x squared term, you're going to have a 64. Now, I know that because my major axis is my focal points are on my major axis, that means that my major axis is the x-axis, and therefore that makes this a squared. So a is always greater than b with an ellipse. So what we know also is that c squared is equal to a squared minus b squared. So c squared being the length here, that's c. So c is 5. So that means this is 25 is equal to 64 minus b squared. So if we take 64 and you subtract 25, okay, you're going to get 39. And so you're going to have 39, negative 39 is equal to negative b squared. So b squared is equal to positive 39. So that means that the other value going up, the square root of 39, and down. So that's roughly a little bit more than 6 and 6 in both directions. So it looks like my ellipse is going to look something like that. And b squared will go underneath here. Oops. So b squared, which is right here, will go underneath my y coordinate. So there. So I'm going to rewrite this as x squared over 64 plus y squared over 39 is equal to 1. And so that's the equation of my ellipse. So just reviewing what we know about circles. We know that standard equation, given the point hk, which is my center, we know that x minus h quantity squared, so x minus h quantity squared plus y minus k quantity squared is equal to my radius squared is my standard equation for my circle. So being hk is my center, r squared is this value here, r is the radius. That happened. Okay. For ellipses, we know that the standard equation is going to be x minus h quantity squared over a squared, y minus k quantity squared over b squared is equal to 1. It means that the a squared term here in an ellipse, a squared is always greater than your b, or a is always greater than b. So what happens here is that if your a is along the x-axis, that means that your ellipse is going to be more flat this way. It's going to come out longer to the right and left like that. Whereas if my a was on my y-axis, that means it's going to be vertical like this. This one's horizontal, that one's vertical. You also have the vertices are here and here for an ellipse. You got your vertices here and here are for an ellipse. You also have these values here, which we either call co-vertices or endpoints. The other co-vertices or endpoints. Your major axis is always going to have your focal points on them. So if my major axis is vertical, that means that my focal points are going to be on that. And then one more thing for this, if you have, to find your focal points, you're going to use the equation c squared equals a squared minus b squared. And that differs from a hyperbola, where you're going to use c squared is equal to a squared plus b squared. Additionally, for a hyperbola, you have the equations x minus h quantity squared over a squared minus y minus k quantity squared over b squared equals 1. If the x term is positive, that means my hyperbola is going to open up horizontally like that on the x-axis. But if my y squared term is positive, that means my hyperbola is going to open up vertically, up and down. Additionally, you're going to have what we call the equation of the asymptotes. And so, for example, if I had, let's say, x squared over 16 minus y squared over 25 is equal to 1, that's a hyperbola. The equation of my asymptotes would be y equals plus or minus the square root of 25 over 16 x. And the x is not underneath the root. And so my equation would be, if my center was at the origin, y equals plus or minus 5/4 x. Okay, and that's, again, only if my center was at the origin. Now, then we came along, we met Mr. Parabola. Mr. Parabola, what that is, this is an equation that goes upside down. So therefore, this graph of this equation is y equals negative x squared. But then that one goes up and down. We have this equation, which is y equals positive x squared, which is going to go up like this, vertical. Then we have the equations x equals y squared. The graph's going to go to the right because that's positive. And then we have x equals negative y squared, and that's going to go to the left. Please keep in mind that if you notice all of these, I have the x squared term or the y squared terms all on the right-hand side. So just as a sort of starting point. Additionally, parabolas have focus points, just like a hyperbola and an ellipse. And if you notice, it's also in the curvature, whereas a hyperbola looks like this, also has the focus points here, and an ellipse also has the focus points, see, like that in the curvature. That's always going to be in that arc, just like a parabola. Parabola, some attributes to a parabola are that, if you notice, if you see this here, so you've got the 4p times the quantity y minus k equals x minus h, y minus k equals x minus h quantity squared. A lot of people will write your equation just like this. However, I prefer to write my equation like this, 1 over 4p times the quantity x minus h squared. So I always write this value right here next to my squared term. So that's something that will differ from different teachers, but you can always write it in front here or like this. This also can be rewritten as an a term. With parabolas, the distance from the vertex to the focus, we call that p. And also the vertex to the directrix, which is right here, that distance is p. So those are the same distance, so that helps when we're trying to find that equation. So let's get to some examples. So we're going to start off with writing an equation for the parabola that has a vertex of 5, negative 2. So this point goes right here, and I like to put a v there. So that's 5, comma, negative 2. My directrix is y equals negative 5. So that means that my graph is going to, my line right here for my directrix is going to cross the y-axis at negative 5. So that's going to look like this and go through like that. So this is at negative 5. Remember, this is 5, negative 2, and this is my directrix. So what's going to happen now is, in making this equation, remember that this distance from here to here is p. It also means that my parabola is going to arc up like this, okay? Because the directrix is always on the other side of the focus point, which is going to be around here. Remember, if this is 5, negative 2, so this length down here is negative 2, and then I go down 3 units, 3, that value, I'm going to also go up 3 to get to my focus. So if this is negative 2, this point right here is going to be 5, comma 1. So that's my focus point. Writing the equation, I notice that my parabola looks like this, y equals x squared. So putting in those point values, we're going to go y minus k is equal to a times the quantity x minus h quantity squared. So what we have here is my vertex is at 5, negative 2. So we're going to go y plus 2 is equal to a times the quantity x minus 5 quantity squared. So we know that a, we're almost there with the equation, we know that a is equal to 1 over 4p. We know that p, this distance from here to here, is 3. So therefore, this value here is going to be 3, so it's as if it's 4 times 3, which is 112. So my equation for my parabola is going to be y plus 2 equals 1 over 12 times quantity x minus 5 quantity squared. And so that's the equation of my parabola. Keep in mind that if you did write it the other way, you could write this as 12 times the quantity y plus 2 equals the quantity x minus 5 squared. So like I said, a lot of people write it that way. It's just a preference, whatever you prefer. The next question says, find the equation of the parabola that has a focus at -3, 4. Okay, so let's see. Let's bring this up a little bit. I have a focus point at -3, 4, so graph that. So over 3 and up 4. So there's the focus point. I put an F there. That's -3, 4. This being 4. I have a directrix at x equals 7. So that means that I'm over here at 7. And so if it's x equals, my line is vertical and it pierces through that. Remember that your vertex is halfway in between your focus point and your directrix. So that means that this distance is -3 here, and this distance is 7 here. That whole distance is 10 from here to here. So if that's 10, that means that I'm going to go over 5. So we're going to go 1, 2, 3, 4, 5. Right there is my vertex, and that point is 2, 4. So that means that my graph is going to curve around like that. Okay, so what we have now is, remember, my graphs, if I had y equals x squared, my graph would look like that. If I have y equals -x squared, my graph does that. If I have x equals y squared, my graph goes to the right. But if I have x equals -y squared, my graph goes to the left, which is what I have here. So remember, h always goes with x. So we're going to go x minus h equals my a times y minus k quantity squared. So that's my equation right there. But we also know that this term right here is negative. Okay, so that is negative. So what we're going to do is, from our vertex, we're going to go x minus 2 equals a, which is going to be 1 over 4p. Now, p is this distance from my focus to my vertex. So if this is -3 and this is 2, that means that my focus is, or that distance is 5. So p is equal to 5. So this will be 1 over 4 times 5 times the quantity y, this is my y, where's my vertex? 4. So it'll be y minus 4 quantity squared. So my final equation will be x minus 2 equals 1 over 20 times the quantity y minus 4 quantity squared. And then we're just going to box that up. Okay. Also, again, if you were writing this a different way, you would write it as 20 times the quantity x minus 2 equals y minus 4 quantity squared, and that's fine. It's just not my preference. Okay, so the next problem says, determine what kind of conic it is, and then write it in standard form. So for this problem right here, you always look at the two squared terms, or if there's just one, you know it's a parabola. This is a square, this is a square. These terms, the 4 is different than the 1. Therefore, if they're both plus and the values are different, this is called an ellipse. Now, for this problem, if I have an x squared term and an x, that means I need to complete the square for x. If I have a y squared term and a y, that means I need to complete the square for y. So what we're going to do is, for this problem, is I'm going to complete the square 2 times. So I'm going to group my x's and y's. So I'm going to go x squared plus 6x, and then I'm going to group my y. So I'm going to go plus 4y squared minus 8y is equal to -9. So now I'm going to look at this and I'm going to say, well, I can complete the square if my squared term is 1, which it is. But for this problem here, I'm actually going to need to factor out that 4. So here we go. We're going to go x squared plus 6x. Half of 6 is 3. 3 squared is 9. Remember, what whatever you add to one side of an equation, see the equal sign here? Whatever you do to one side of the equation, you do have to do to the other side also. So now we're going to factor out this 4, and then we're going to get y squared minus, factor means divide. So we're actually dividing out a positive 4 out of that, so that's a 2y. Now to complete the square, we're going to take half of 2, which is 1. 1 squared, still 1. And then we have negative 9. Now, whatever I added to the other side, I need to add again onto the right. So I'm going to add 9 here. And then I'm going to add 4 times 1, which is plus 4. Because even though I'm adding 1 right here, see this 4? I temporarily factored that out. I have to put that back in. So now just factoring, we're going to get x plus 3 quantity squared plus 4 times the quantity y minus 1 quantity squared is equal to 4, because the 9s are going to cancel. I'm going to divide through the 4 because for something to be in standard form, you want it to equal 1. So we're going to get rid of that. So we're going to divide everything out by 4. And in doing that, I end up getting x plus 3 quantity squared over 4 plus, parenthesis, y minus 1 quantity squared over 1 is equal to 1. My vertex is going to be at negative 3, 1. There it is. And we already know it's an ellipse. So that means I'm looking for my major axis, which is the bigger number, which means that's a squared. That means that's b squared. So for my ellipse, after I've made my center being negative 3, 1, in the x direction, I'm going to go the square root of 4 to the left and to the right. So I'm going to go 2 to the left and 2 to the right, okay? And then additionally, I'm going to go in the y direction, the square root of 1, so which is 1 up and 1 down. So my ellipse looks something like that, okay? I have focal points that are going to be on the major axis, and so I'm also going to want to know what the value of my major axis is. So my major axis is equal to 2a. Well, if a squared is 4, that means a is 2. So 2 times 2 is 4. My minor axis is going to be the square root of b squared, which is 1. 2 times 1 is going to be 2. So that's the length of my minor axis. Okay. You also need the values of your focal points. And so that means for this problem, which is an ellipse, c squared is equal to a squared minus b squared. So therefore, c squared is what we're looking for. A squared is 4 minus 1. So c equals the square root of 3 plus or minus. So remember that if your center is not at the origin, then you're going to need to add this value right here to the vertex or to the center. So if my center is at negative 3, 1, and my focal points are always on my major axis right here, then I'm going to add those points to this number, negative 3. If my major axis was on the y-axis, then I would add those numbers to 1. So we're going to go, for this, we're going to go negative 3 plus or minus the square root of 3, comma, 1. And so those are the points where my focal points are going to be. Name the conic and write it in standard form. So looking at this equation right here, I notice that I only have one squared term. So that being said, if I have just one squared term, that means it's a parabola. And so let's see what we're going to do. Let's group this. So I have x squared minus 6x is equal to 2y minus 9. I notice that I do need to complete the square because I do have an x squared term and an x. I'm going to change this up because I do prefer to have my squared terms on the right. So I'm just going to rewrite this. 2y minus 9 equals x squared minus 6x. Now, completing the square, we're going to take half of 6, which is 3, 3 squared, which is 9. So I'm going to add 9 to both sides. We're going to get the quantity x minus 3, quantity squared. We're going to get 2y, and then it looks like my 9s are going to cancel out. I'm going to put this in the form. Now, remember, if you leave it like this as this form, this right here, this 2, c minus 0 there, that becomes your 4p. If you don't write it like this, you would go y equals 1/2 the quantity x minus 3, quantity squared. I know that my vertex for my parabola is going to be at 3, 0. So at 3, 0. So going over 3, 0, there's my vertex. It looks also like this is a y equals positive x squared, which means then my graph is going to go up like that, open up. So a couple of things you're going to need to put on here, like your focus point. And so remember, this is going to be in standard form. It means also that this value right here, 1/2, is equal to 1 over 4p. So 4p is equal to 2. So p equals 2 over 4, which is 1/2, which means that the distance from here to my focal point is 1/2. That is 1/2. It also means that the distance down here from my vertex to my directrix is 1/2. So the equation for my directrix is going to be y equals negative 1/2. And the point of my focus is going to be 3, positive 1/2. Okay. For this problem, it says determine the conic and write its components. I have a positive x squared and a positive y squared. So that means it's an ellipse. They've already completed the square here. So actually, all I have to do for this problem is graph it and write down the components. So what we do know for this problem here is that my center of my ellipse is going to be at -2, -2. So that's going to be at -2, -2 here. It means that my graph in the x direction, I'm going to go the square root of 9, which is 3. So 1, 2, 3. 1, 2, 3 to the left. It means that in the y direction, I'm going to go the square root of 4, which means up 2, down 2, so that my ellipse now looks like this. Oh. So my ellipse looks like this. It also means that my major axis is on the x-axis going across like that. See, that means this is larger, which means that is equal to a squared, and this means this one is equal to b squared. So my major axis being 2a, if a squared is 9, a is 3, so 2 times 3 is 6. My minor axis is going to be 2 times b. B squared is 4, so that means b is 2, so 2 times 2 is 4. You can also just count up and down. Let's see, my focal points are going to be at c squared equals a squared minus b squared. So that c squared is going to equal 9 minus 4. So c equals the square root of plus or minus 5. So again, my focal points are going to be on the x-axis because that is the larger axis, my major axis. So therefore, if my center is at -2, 2, so -2, -2, my focal points are going to be at -2 plus or minus the square root of 5, comma, -2. That means that they're going to go -2 and then more, and then -2 and then less. Let's see. Oh, just a note that these, if you get a question where it says, what are the points of your vertices? The vertices are all the ones on the major axis. So therefore, you would say, if that was over 2 to the left, and if you went 3 to the right, this point right here would be 3, -2. And then this point also would be another vertex. And you have to make sure that you label your points and your vertices. These values up here are your co-vertices. Those are your co-vertices. Some people call those endpoints. So this problem right here says determine the conic and write it in standard form. This equation right here, if you look at the two squared terms, is minus. So this must be a hyperbola. So therefore, if this is a hyperbola, okay, let's start completing the square, seeing if I have to complete the square. First, I'm going to group my terms. So I have 4x squared plus 8x minus 3y squared. I'm going to move this 16 to the other side. It's not attached to anything. So what it looks like here is I have an x squared term and an x. So that means I have to complete the square. But I have a y squared term, but no y. So I'm only actually completing the square one time. So we're going to factor out the 4. You're going to get x squared plus 2x. Half of 2 is 1. 1 squared is 1. then I've got negative 3y squared equals negative 16. Now remember, you temporarily factored out that 4. You need to put that back in now. So we're going to add 4 to that. So what we have is 4 times the quantity x plus 1, quantity squared, minus 3y squared is equal to negative 12. Well, what I need to do now is divide by negative 12 to make this 1. Because remember, in standard form, for the equation for the hyperbola, you need a 1 there. So we're going to divide everything by negative 12. And in doing that, that actually changes my negative sign. So what I have now is x plus 1 quantity squared, negative here, over 3, plus y squared term over 4 is equal to 1. So here's my equation of my hyperbola. It also means that my vertex is, or my center, not my vertex, my center is going to be at negative 1 comma 0. So negative 1, 0. In the x direction, I'm going to go the square root of 3. So the square root of 3 left and the square root of 3 right. In the y direction, I'm going to move my square root of 4. So that means 2 up and 2 down. Now remember, this is a hyperbola, not an ellipse. So if this was an ellipse, I would certainly connect all my points. But because this is a hyperbola, I'm going to make this box around here. I'm going to put in my asymptotes here and here, okay? And therefore, the last thing I'm going to do is I'm going to realize that my y squared term is positive. So that's my vertice right here, and that makes this my vertice. And therefore, my graph is going to arc up this way because y is positive. It's always on the positive axis. That being said, it also means that this number right here is a squared. It means that value there is b squared. Okay, a couple of things to remember, that you do have focal points. So c squared equals a squared plus b squared. C squared is equal to 4 plus 3. So c is equal to the square root of 7 plus or minus. So plus or minus from the y coordinate are going to be my focal points. So that's my focal points, foci. So that means that from my center, because it's on the y-axis, it's going to be negative 1 comma 0 plus or minus the square root of 7. So those are my foci. Additionally, you do need to know what your transverse axis is. And so the transverse axis is the axis that connects the two vertices. So this is my transverse axis. And then the other axis, which really doesn't connect anything other than the endpoints of the box that holds the asymptotes, that's called the conjugate axis, okay? And so we really don't graph that. It's just not really holding anything. From negative 1, 0, you also have asymptotes. But you can also find the asymptotes by just rise over run, meaning 2 over the square root of 3. So that value is like a decimal of some sort, but just know that that's how you would find that. Rise over run, so you would go the square root of 4, which is 2, over the square root of 3 from your center, wherever that is. This conic right here, it says determine the conic. See how they're both plus and they're both x squared? This conic is an ellipse. It's an ellipse because they're both plus and the values here are different. That's a 1, that's a 9. Because what's going to happen is when I divide out that 36, they're going to cancel out. So what's going to happen is that, see 36 here, divide out 36 here, divide out 36 here. So you're going to have x minus 1 quantity squared over 4 plus y plus 3 quantity squared over 36 is equal to 1. So this is my equation in standard form, and it is an ellipse. My center of my ellipse is at 1 comma negative 3. So let me move this graph up here. I really believe in graphing all of these so you can visually see the same thing. So you're going over 1 and then down 3. So that's my center. From my center, I'm going to go 2 to the left and then 2 to the right, because that's going to be the square root of that value. In my y direction, which is my a squared, this is my b squared. Because in an ellipse, a squared is all a is always greater than b, okay? In the y direction, I'm going to go 6. So up 6 and then down 6. So my ellipse looks like this. It means that my major axis is now along my y-axis. That also means that my focal points will be on my y-axis. So let's figure out exactly where those are going to be. We know where our vertices are. Vertices are here and here. This value here being my focal points. C squared is equal to a squared minus b squared. That's how I find my focal points for an ellipse. So c squared is going to be equal to 36 minus 4. So c equals plus or minus the square root of 32, which is the square root of 16 times the square root of 2, or 4 root 2, plus or minus. So that means that for my center, I'm going to take my center to make my foci, and I'm going to go 1 comma. Again, because my foci are on my y-axis, I'm going to add the foci to my y-coordinate. So negative 3 plus or minus 4 root 2. Let me move that over. Okay, and then this one will go like that. Okay, so those are my focal points. You're going to need to know the length of your major axis. So the major axis is 6 this way and 6 that way. So that makes the major axis is 12. And my minor axis is going to go the smaller axis. And so that's going to be the square root of 4, 2 to the left, 2 to the right. Write the equation of a parabola that has a focus of 0, 4. So there's my focus point at 0, 4. My directrix is at y equals negative 4. So that means my graph that goes through my y-axis at negative 4. So that's y equals negative 4. This value is positive 4. So it means that halfway in between here is going to be my vertex. And my vertex is always going to cut my focus point like that. So what we have now is that I have a focus point for my vertex. I have a p-value. So p is equal to 5. So write the equation of a parabola. This looks like a y equals x squared graph. So we have y minus k equals a times x minus h, quantity squared. So my vertex here is at 0, 0. So that's just y minus 0 equals a. A is 1 over 4p times the quantity x minus 0, quantity squared. P being 5. So we have y equals 1 over 20. Times the quantity x squared. So this is the equation of my parabola, and that's it. Oh, and you could put the 20 here if that makes you happy. I prefer it the other way. Determine the conic, and this equation I have both x squareds and y squareds, so that means that it's either an ellipse or a parabola or a circle, but because I have this negative sign here, that makes it a hyperbola. Okay, now, secondly, for this to be in standard form, this value here needs to be a 1. So I'm going to divide through everything by 9. And so what I have here is negative x minus 3 quantity squared over 9 plus y minus 2 quantity squared over 36 equals 1. So now what I have here is a vertex or a center at 3, 2. So over 3 up 2. So there's my center. In the x direction, because it's a hyperbola, remember I'm going to make the box. So in the x direction, I'm going to go 3 to the left and 3 to the right. In the y direction, I'm going to go 6 up and 6 down. Oh, and I'm not going to make this into a hyperbola. I'm going to make this into a box, like I said. And so make the box this way up, over like that. Put in your asymptotes this way, this way. Remember, from your center, your asymptotes are going to be rise over run. So it's up 6 over 3. X, like from that center, that's where they would go. Write the components. We wrote the center. We would say that my transverse axis, which is the positive axis, would be 2 of those. So square root of this is my a squared, so it'd be 2a. So that's going to be 12. My conjugate axis is going to be 2b, which is, if that's b squared, that's going to be 2 times 3, which is 6. And my focal points. And I also have to graph where the the hyperbola is. Because y is positive, my graphs are going to be up and down here. That means that point and this point are my vertices. You are going to have to label those, so just be aware of being able to do that as you're graphing. Lastly, for my focal points, I know that my foci are going to be at c squared equals a squared plus b squared. C is equal to the square root of, let's see, that's a b, a squared plus b squared. C is equal to the square root of 36 plus 9, which is 45, so plus or minus square root of 45, which is going to be the square root of 9 times root 5, so 3 root 5, so plus or minus 3 root 5. Now, keep in mind, those are always going to be in there, that in the arc, right, in that arc. So to label that point, you go from the center, and you're going to go, let's see here, it's on the y-axis. So my focal points are going to be at, let's see, 3, 2 plus or minus 3 root 5. And that's those are my foci points. All right. Determine the conic and write it in standard form. This right here is a hyperbola because you have two squared terms and you have two squared terms and you have one negative sign. So we're going to complete the square probably at least once. Let's group these, and I'm going to group the x's together. So I have negative x squared minus 18x. Now I'm going to group my y's. Plus 4y squared minus 8y is equal to 41. I'm going to move this over to the other side because it's not with anything else. We're going to factor out the negative 9. So when I do that, I end up getting x squared plus 2x. Half of 2 is 1. 1 squared is 1. I'm going to factor out a 4, and I get y squared minus 2y. Half of 2 is 1. 1 squared is 1. Then I'm going to get 41, and I'm going to add, let's see here, negative 9 times 1. So I'm going to add negative 9. And then 4 times 1, which is 4. So I'm going to add 4. So what I have here is, let's see here, 41 plus 4 is 45. And if I subtract 9, that's going to be 36. So that means that when I simplify this a little bit, I'm going to get negative 9 times the quantity x plus 1, quantity squared, plus 4 times the quantity y minus 1, quantity squared, is equal to 36. I'm going to divide everything by 36 because for this to be in standard form, this has to be 1. So what I have here is negative x plus 1, quantity squared, over 4, plus quantity y minus 1, quantity squared, over 9 is equal to 1. So again, this is a hyperbola where y is positive. For my center is at negative 1, positive 1. So my center is at negative 1, 1. So that's going to be right here. In the x direction, I go the square root of that value. That value being the negative, so that's my b. For a hyperbola, the term that is positive is your a squared term. So this is my a squared term. So in the x direction, though, I'm still going the square root of 4, which is 2 to the right and 2 to the left. In the y direction, I'm going to go the square root of 3, which is 3 up and 3 down. Okay, so let me move that up a little bit. Okay, remember, this is a hyperbola. So therefore, you're not going to connect the dots. You're going to make this into a box. You're going to put your asymptotes in, meaning you can also go rise over run. Look, up 3 over 2, rise over run. Okay, from your center. And then here's my other asymptote. Okay, because the y is positive, again, my graph is going to go up. So that's a vertice. It's going to arc up that way and left. And then this is a vertice here. It's going to arc down that way and that way. Lastly, we need to put in our focal points. So c squared equals a squared plus b squared. So c is equal to plus or minus the square root of 9 plus 4, which is 13. Again, because this is along the y-axis. I'm going to put my focal points here and here, but the value of that point is going to be parenthesis -1, comma 1, because y, I'm going to add that to my y coordinate, y or 1, plus or minus the square root of 13 and quantity. Determine the equation for the parabola that has a focus of 0, 2. So 0, 2 is my focus point, and my vertex is at 0, -4. So that's down here at 0, -4. Okay, and then this was at 0, 2. It means that halfway in between, oh, that's my vertex. So this is V. So that means that the distance of P, if down 4 and up 2, so P is equal to 6. So therefore, let's see here, vertex, focus, it's going to have to look like this, right? Because the focus point is always in the arc. So that's a y equals x squared. So we're going to go y minus k equals a times x minus h, quantity squared. It means that halfway in between, if that's 6, I'm going to go down 1, 2, 3. So 0, -1 is my vertex. So 0, -1 is the vertex. So that means that if 0, -1 is the vertex, that goes with x, this goes with y. So it's going to be y plus 1 equals a times the quantity x minus 0 squared. Now, p is 6. That makes a difference because remember what this equals right here, the a? A is equal to 1 over 4p. If p is 6, then I'm going to go y plus 1 equals 1 over 4 times 6, 24, times the quantity x squared. So this is my equation of my parabola. Remember, not a problem. I could put the 24 in front if you prefer that, is equal to x squared. And there's my equation of my parabola. To put this in standard form, you would say that it's a plus and a plus. So I'm going to group, it's got to be an ellipse. Okay. We're going to group our squared terms. So we have 2x squared plus 8x plus y squared minus 16y is equal to -52. So I'm going to factor out a 2. I'm going to get x plus 4. X squared plus 4. Half of 4 is 2. 2 squared is 4. Plus y squared minus 16y. Half of 16 is 8. 8 squared is 64. Is equal to -52. Remember how we temporarily factored out this 2? We're going to multiply that back in. So that's going to be plus 8 and then plus 64. So what I have is 64 plus 8 is going to be 72. And then 72 minus 52, all right, 0, that's 20. So what we have is 2 times the quantity x plus 2 squared plus y minus 8 quantity squared is equal to 20. I'm going to divide by 20 everywhere here. And so my equation now for in standard form is going to be x plus 2 quantity squared over 10 plus y minus 8 quantity squared over 20 is equal to 1. So there's my equation of my ellipse in standard form. I have a center at -2, 8. So I'm going to go -2, 8. So I'm going to move my graph down a little bit. Okay, so I have -2, 8. So -2, 8. Whoops. So -2, 8 is right here. So that's my center. In the x direction, I'm going to go the square root of 10, which is about 3 to the left and 3 to the right. When I go the square root of 20, that's up. That's like 4.5 up and 4.5 down. So this is an ellipse. I'm going to connect the point, the vertices here all the way around, so that my major axis is along here. Now to figure that out, this is equal to a squared, and this is equal to b squared. Remember, a is always greater than b. So if a squared is equal to 20, that means a is equal to the square root of 20, or the square root of 4 times 5, so 2√5. So what that means is that this distance going up is like or my vertice up here is going to be, so I'm going to have to know what that vertice is. So that's going to be negative 2, comma 8 plus 2 root 5. And that's going to give me that vertice here. Additionally, if this is A, that means that this value here, to get my major axis, I'm going to go 2A. So that means 2 times 2 root 5, which is 4 root 5. So that's actually the length of my major axis. And the length of my minor axis is going to be 2 times the square root of 10. Okay, and that's my length of my minor axis. Find the equation for the hyperbola that has vertices at 8, 14. So over 8, oh, looks like I'm going to run out of room. So let's do this. So 8, 14, so over 8, so here's 8. And up 14, so we'll say, let's continue this up and say that's 14. And so that's one of my vertices, 8, 14. And 8, negative 10, oh boy. So then 8, negative 10 is down here, so that's 8, comma, negative 10. So those are my vertices, which means that that's my hyperbola, so that means that's my transverse axis. So if I went down 10 and I went up 14, that makes 24. So that means halfway through is 12. So that also means that this point right here at 8, comma 2 is my center. That's the center of my hyperbola, which means that this is going to start off as x minus 8 quantity squared. It's going to have a y minus 2 quantity squared, and I'm going to have it equal 1. Additionally, because my vertices are on my y-axis, that means my y-coordinate is going to be positive and x is going to be negative. The distance between here and here, okay, that's my a value. Okay, so if I went up 2 and I went to 14, that means 10. So that means underneath y is 100. Now, what else did they tell me? They told me that my conjugate axis is 6. So that means I went to the left 3 and to the right 3. So that's just simply a 9. And so that's the equation of my hyperbola. This one says, find the intersection of the two equations. So that's cool. This one right here is a parabola. And this one here is a line. And I would always suggest that you graph these and solve algebraically. So for this one right here, I'm going to have to simplify first. So moving the 2 over. So we're going to go y minus 2 equals x squared plus 3x. Now, completing the square is not going to be pretty. But that means that, see, that's not a nice number, but that's okay. We're going to take half of 3, which makes half of 3, which is 3 halves. Square that is going to be 9/4. So I'm adding 9/4 to this side, and then actually I'm going to add 9/4 to this side. Factoring that, it's going to be x. Remember, you take the square root of that and the square root of that. So that'll be x plus 3 halves, quantity squared. Here, it'll be y, and then I'm going to need to fix that. So I need a common denominator, which is 4. So that looks like it's going to be negative 8 plus 9, which is 1, positive 1. So plus 1 4. So it tells me that this is my standard form of my equation of my parabola. It also tells me that my vertex is at negative 3 halves, comma, negative 1/4. So negative 1.5, negative 1. So there's my vertex. Because it's a y equals x squared, I know my graph is going to go up like this. I just don't know, how wide is it? How wide is it? This, remember, this is 1 here, 1 over 4p, right? If p is, this is equal to 1, so 4p is equal to 1, so p is equal to 1/4. So it's sure not very, that's not a very, it's not very far. My focus point is not very far. Now, that's not helping me solve this, so I'm going to erase all that. So all that did right now was graph my parabola. So I checked, I did that. Let's also graph our line. There's my line. I'm going to start at 3. So I'm going to go up 3. There it is right there. My slope is up 2 over 1. So there's my point. So it looks like that my graph is going to go through this like that, okay? Where my intersection points are, I have no idea. They're they're going to be right here somewhere, right? And then they're going to be right here somewhere. But I'm not sure where that is until I solve it graphic or algebraically. So to me, this looks pretty straightforward in that, see how they're both equal to y? I think the simplest method for this is just to set the y's equal to each other. Okay, so we're going to solve this algebraically by setting y's equal to each other. So we have x squared plus 3x plus 2 is equal to 2x plus 3. I notice that this is quadratic, so I do need to set my quadratic equal to 0. So I have x squared. I'm going to subtract 2x from both sides, and I'm going to get plus x. I'm going to subtract 3 from both sides, and I'm going to get minus 1 equals 0. So what this does for me is this is going to give me, let's see here, x squared. Oh, that's a 2x. So if I move the 2x over, I do get 1x. And 3, if I move the 3 over, I do get minus 1. So I'm going to have to use the quadratic formula because this is not going to factor. So we go x equals the opposite of b plus or minus the square root of b squared 1 minus 4ac all over 2a. So let's see what this looks like. Negative 1 plus or minus 1 plus 4, which is 5, square root of 5 over 2. Oh boy. So those values, I would just think I would just use a decimal at this point, because for me, what I have to do is once I find that value, I got to plug it in to find my y value. So you're going to need to find the approximation of this point and then go from there. Okay, so I'm going to let you finish that problem because I don't have a calculator. For this problem right here, this is a parabola again and another parabola. So for these two parabolas, again, I would set the equations equal to each other. 2x squared plus 3x plus 4 equals x squared plus 2x plus 3. I would subtract x squared, so I have x squared. Subtract that, I get plus x. Subtract that, I get plus 1. Is this the same exact problem? I feel like this is the same problem. Anyway,